C, when is it moving to the right? For velocity, when you set it equal to 0, and I know some of you have different equations, did you get velocity equal to 0 at 2 and 5? So we should have 0 to 2, 2 to 5, and 5 to infinity, right? I pick a number in each one, put it in velocity. If it's positive, it's right. If it's negative, it's left.
Okay.
So you should be able to figure out which interval it's moving right.
So, okay. So you did T1.
Yes.
Yes.
Now,
so for D, does that mean you set acceleration equal to 0?
no, D is velocity. When is velocity decreasing? Means when is
Acceleration downward. Acceleration negative. That's what I would assume.
when is velocity decreasing? That means, yes, acceleration equal to 0, you set it up, and acceleration, so what I have for this is I have 2 and 5, and velocity, and did you get this? Then we're going to set acceleration equal to 0, and for acceleration I had 0 to 2, 2 to 4, and 4 to infinity. So I need a 4 right here, right? And acceleration, did you do it?
Yes.
I got this. Right?
So is velocity negative until 5?
Yes. Now, when is velocity decreasing? Velocity is decreasing when acceleration is negative.
Is it just opposite?
Well, what?
So, is decrease whenever they're opposite of each other, or is that?
No. Decreasing just means when acceleration is negative, because it's decreasing or increasing when the derivative is positive or negative.
It's the speed.
And acceleration, it's speed that's both of them.
Yeah.
And that's where we're going to get there with E.
So
it's just 2 to 4?
On D,
Yeah.
yes. And then E, when is the speed increasing? When they are both acceleration and velocity positive or both negative.
Okay.
Do you remember that?
Yes.
The difference was velocity decreases. That is the derivative of velocity, not both of them together.
Can you say E one more time?
Say what?
This is making
B. For B, you want to know when acceleration is negative and velocity is, or excuse me, acceleration is 0 and velocity is not 0. So I have the zeros of acceleration. They are 2 or 4. So which one of those, when I plug into velocity, is it not 0?
Well, whenever I plug it, I didn't get 0 on either of them. So is that?
Well,
Do I plug that into acceleration?
you want acceleration to be 0. And acceleration is 0 at 2 or 4. Right?
height.
Okay.
allowed to ask questions on the free response question?
Not right now.
Okay. 'Cause
No, we will do that tomorrow.
I will get a 0. I'm just gonna.
Well, I gotta get some. Rolle's theorem. Rolle's theorem says if I have a continuous function from A to B, and if, that's a bad F, but if f of A equals f of B, then somewhere in there, f prime of C has to equal 0.
Rules theory. Rules.
What it says is I have a function. Here's A and B. It is continuous. This y value is the same as this y value.
Yeah.
Does it make sense to you somewhere in there, the derivative, or it has to go up and down or down and up? That's what Rolle's theorem says. Somewhere in there.
Down and up, like where?
Doesn't matter where, like that. Is that a 0?
Is it?
Or up and down? Is that a 0?
Straight line. It'll just all be 0.
Well, the derivative's still going to be 0, isn't it?
Okay. Just making sure.
So, can we work a problem with this? All right. Here is my equation. F of x equals x cubed minus 9x plus 1. Okay? I want to know, first of all, does Rolle's theorem apply? And if so, where does it happen? If it applies, it means f of 0 equals f of 3. What's f of 0? 1. What is f of 3?
9.
1. Right? So it applies. That means somewhere in there, the derivative equals 0. For what x value does that happen? The derivative is 3x squared minus 9 equals 0, correct? Is that right? So x squared equals 3.
Will we have to write Rolle's theorem or something if we're doing this on the test?
Probably not. It probably will be a multiple choice. What is x? Plus or minus what? But, which one is my answer?
None of the possible.
It has to be in my interval. X equals radical 3? That's Rolle's theorem.
We're just trying to find x and that's it.
Yeah,
Okay.
that's Rolle's theorem.
Okay.
Now, the second one we're going to talk about,
So what do we do if Rolle's theorem doesn't apply?
then it doesn't work. You can't get an answer.
Oh, okay.
Mean value theorem.
Oh, I remember this.
The mean value theorem says if it's continuous on a closed interval and, of course, differentiable, then somewhere f prime of c is f of b minus f of a over b minus a. This time I don't care if f of a equals f of b. What this means is if I have a function, I have a point here and a point here. Whatever this slope is, somewhere when this goes from here to here, it has to have that slope up there. Somewhere.
Oh, okay.
That's all that
At a
means.
single point. Okay.
maybe 10 single points. But somewhere it has the same slope. So can we work a mean value theorem? Here is my function, f of x equals x cubed minus 2x squared plus x minus 5.
Fun.
What?
Is it fun?
-1 to 2.
And those would just be the y values, right?
No, those are the x values. That's the interval.
Okay.
So,
Oh, we're trying to find out if they're on the same, so if they were on the same line, we use Rolle's theorem. They were like that.
if they were equal to each other. Okay, what is my derivative? 3x squared minus 4x plus 1 has to equal, what is b?
2.
2. What is f of b? Did you do it? -3? Minus, what is f of a?
Students with a brain. Think that.
Is that, are you plugging the -1 the first one?
So,
Yes, because it's not f prime of a, it's f of a.
single one's minus
So plus 9 over 3. We agree with that? So does 3x squared minus 4x plus 1 equal 2? So what is x? And by the way, this would be a calculator one because it will not factor. So anytime it gives you a calculator one and you're doing this for time use Polly Smart. Okay? Don't waste your time on factoring. You know how to factor. If it's a calculator one. Do you have an answer? $1.549, and what else? Do they both work? When I say do they both work, what do I mean by that? Are they in the interval? Right. Good with that? Those aren't bad, are they? And I know sometimes when you get to the problems, you're thinking they weren't bad until we tried to work the problem. Okay? Now, let's talk about extrema, maximum and minimum. Do you know what it means when it has a maximum or a minimum? Do you know what critical numbers are?
critical angle? Yes.
No, critical numbers. Numbers that affect the problem. For instance, if I have a graph that looks like this, whatever this x value is would be a critical number because it causes the graph to do something. If I had a graph that looks like this, whatever this is a critical number because that's where the graph turns around. Understand those are critical numbers? Remember with another time we dealt with it when it didn't have a derivative, when it had a vertical tangent? That would be a critical number. Right? Now, we we deal with this, what do I know about the derivative right there? Is it going to be positive or negative?
Non-positive.
Positive. Over here it would be negative, right? You all agree with all that? So, if I give you f of x equals x to the 1/3 times x minus 1 squared, all I want to do is find the critical numbers. The critical numbers are when f prime equals 0 or when f prime does not exist. Because in this, right here, f prime doesn't exist. F prime doesn't exist. F prime equals 0. So I need to find f prime, decide where it's 0 or where it doesn't exist. That's how I find critical numbers. All right? So, derivative, right? Is that a product? Which is the first. What's the derivative of the second? Okay. Plus the second. What's the derivative of the first? 1/3 x to what?
Stuff.
So do I have x to the 1/3 times 2x minus 2 plus x minus 1 squared over 3x to the 2/3. Right? Will you agree with that? Where does it not exist? When the denominator is 0. When is that? When x is 0, that's my first critical number. Make sense? Okay. Now, I said I wanted to know when it didn't exist. So my first critical number is 0. Now what do I want to do? Now when the derivative is what? Equal to 0. So I let this equal to 0. Now, I don't know about you. We talked about this the last couple days. Isn't it easier to cross multiply?
I was saying, wouldn't one be better than single?
I don't know.
Well,
I don't know.
if you plug 1 into the top of the denominator, you get 0, and that should be in 9, and then 2 minus 2 is 0.
So you think you can find one that way? So he's got a 1. You all agree with him?
It equals 0.
What he says is if he plugs 1 in, he just looked. This would be 0, and this would be 0. That was an easy one to find. We still don't know if that's all of them. So is negative x to the 1/3 times 2x minus 2 equal to x minus 1 squared over 3x to the 2/3? What am I going to do now?
Yeah. Well,
When I do, I have negative 3x times 2x minus 2 equals x minus 1 squared, right?
oh, you just added, okay, yeah, that's cool. You just added the tops.
Got rid of my fraction, didn't I? So now, do I have negative 6x squared plus 6x equals x squared minus 2x plus 1.
Couldn't you just taken a 2 out of that one and then just, and then you cross?
You cannot divide them out. You will lose an answer.
Okay.
So, negative 7x squared, right? Plus 8x minus 1 equals 0. What do I do?
All these small.
Polysmalt? Try to open the door. I think it gets warm in here with the door shut. Maybe we are not going to be yelling. What? You might know what 143 is? 17. So there's my critical numbers, 0, 1, and 17. This, you may not have remembered it at the beginning, but this should come back to you. The finding critical numbers, what they are. Make sense? Now, what if I want to find a absolute minimum and maximum value? What does absolute mean?
It's the highest or lowest on the whole graph.
Right. Right. So, if I have f of x is equal to x to the fourth minus 2x cubed, my interval is negative 1 to 3. I want to find the absolute minimum and the absolute maximum. Is it true a minimum or maximum happens when the derivative is 0?
Yeah.
Right? So I want the derivative equal to 0. So 4x cubed minus 6x squared equals 0. Right? I'm going to factor out a 2x squared. Gives me 2x minus 3. Where are my zeros?
So 0.
And
Uh,
3 halves. Could a minimum or maximum occur at the end point?
No, or yes.
Yes, it could, couldn't it? So what I want f of 0. I want f of 3 halves. What? No.
oh, you can just.
This, yes. Yes. But you know, you could have factored that fairly if it wasn't. But no, this has to be. Then I want an f of 1 and I want an f of 3.
1, 1, and 3. Oh, okay.
Those are endpoints.
Negative 1. I saw.
Yes. So I need to find a y, correct? Do you know the easy way to do this? The easy way when you have this many is to type this in y equals and use your table or your trace to find the value, so you don't have to retype it every time. What do we have? Well, f of 0 is easy, isn't it? 0. F of -1 is what? 3. I got 3.
That's not the 3. That's -1, I got 3. Okay. I thought we were going to do this.
No. Do we have a 3/2? Nobody has a value for 3/2?
-27/16.
That's what I got.
Everybody's afraid they missed it.
I couldn't get it because my calculator like froze, and now it like I can reboot it or something. It says RAM cleared.
Oh, that's what it did.
I don't know what happened.
It took your,
Still have your program?
no.
Probably not.
And let me tell you something that's going to happen on the AP test. To keep this from happening, there will be extra calculators in the room.
Really?
If your calculator does that, you just raise your hand and they will give you a new one.
Nice. Awesome.
Like,
It has to be. You have to have
Like
it.
the ACT, there's like, okay, deal with that.
But this is different.
Yeah.
The ACT you can take again, and it's not, the calculator's not required. Calculator's required on this. What was f of 3? 27?
Yep.
Okay, guys. What is the minimum?
F of 0. No, -27/16.
I think this one. What is the maximum? This one?
Yeah.
So when you do a minimum maximum test, you have to use inputs. Right?
I remember this stuff.
Good.
It feels like this is much easier the second time around.
That's what I was
It
going to
is.
say.
It is, because the first time it was all foreign. And now you're like, plus we've done it enough, and you're like, okay, you've not only done it, you have used it.
My brain is connecting more
Yeah,
dots.
because like when we first did it, I literally didn't understand how to do this at all, but now it's like,
I didn't understand why we were doing it. Now I understand why we're doing it.
Well, and that's part of, you don't understand why, because it's so foreign to you, you can't
Now I understand.
you can connect it.
It's a critical.
All right. Now, what happens with all our derivative tests? Our increasing, our decreasing, our concave up, our concave down. Do you remember all that?
I do remember it. And I don't hear it maybe just.
So if I give you f of x is equal to 3x to the 5th minus 5x cubed plus 3. I want to find, first of all, a minimum and a maximum.
Is this 3, 5?
Yep.
Wait, when was it 4?
Wait, just 4.
wait, so we're doing 3, 3, 3, 4, and 3, 4?
Uh-huh.
Over the
What do
weekend?
they do?
We'll do questions Tuesday.
Okay.
You thought tomorrow?
Part of time.
No. That way, when we're through tomorrow, you'll work.
What do you mean? Oh, we're gonna be doing more of like this stuff tomorrow? No questions tomorrow?
Just working tomorrow. Other than tomorrow, we're going over that problem.
Oh, yeah.
And then we're working questions Tuesday.
And this has helped me with the worksheet.
It might, yes.
Because I don't know what.
Okay. How do I find a minimum or maximum? That should tell you immediately what to do.
Critical angle.
No.
Critical.
Minimum or maximum,
Critical.
how do I find a critical point?
You set the derivative equal to 0.
Derivative equal to 0. Right? When it sets minimum or maximum, that should click to you, derivative equal to 0. So the derivative is 15x to the 4th minus 15x squared. Correct? When is that 0? And by the way, this is a what did you get?
Oh, no. F9. 4.
I think you got -1, 0, and 1.
0.
So what I have intervals, right? -1 to 0, 0 to 1, and 1 to infinity. Do you agree? I'm going to pick a number from each interval. Where am I going to put it? In the derivative, right? What are we working with? The derivative. That's where we put it. So, I think this is plus.
Yeah. Yep.
I think this is minus.
Okay, how do we get plus the first one?
I put -2 in.
First one would be negative. Second one would be positive. Plus 3.
We plug it in the derivative. No, that's not new. That's the third time I've said that. This is negative.
On the derivative, 0.
This is positive. Right? Okay. Does not ask you when it's positive and negative. It said find a relative minimum and a relative maximum. Does this mean it goes up, down, and up?
No.
So what happens at -1?
It goes down a lot.
At -1, what happens? It's a maximum.
The minimum at 1.
Right? So what is f of -1? F of means the original, doesn't it? Is it 5? Oh,
Yep.
okay. Where is a minimum?
Positive.
And what is f of 1?
Minus 5 plus 3.
1? Okay. Now, I want to know, where is it increasing? Where is it decreasing? Do not say it is positive at. You have to say it is increasing. Where is it increasing?
Minus 5 plus 3.
Negative infinity to -1 and 1 to infinity. Where is it decreasing? -1 to 1? Will you agree with that? Now, what if I wanted to find where it was concave up or concave down?
Look at your little
Don't I do the same thing with what? The second derivative? So what's the second derivative? Okay. So once again, where are my zeros? My zeros are here, and I'm telling you this to save time. You could get the zeros. I set up my intervals from -infinity to negative radical 2 over 2 to negative radical 2 over 2 to 0. 0 to radical 2 over 2, and you could have that as a decimal. And radical 2 over 2 to infinity.
We plug this into the double root.
Yes, that's what we're working with. And I will tell you this is negative, positive, negative, positive. My question is, where is it concave up?
Negative radical 2 to 0. The two positives in this, right?
Okay, it's concave up here and here, concave down here and here. Where is an inflection point?
Now we just have to set the,
Where is an inflection point? When it changes concavity.
negative 2
There's an inflection point
and 2 radical.
when x is negative radical 2 over 2. There's an inflection point when x is 0. There's an inflection point when x is radical 2 over 2. Could I find the y value if I needed to?
You just plug that, the inflection point into the original.
Original, right?